This video will show you how to write an equation of ellipse given some basic criteria. So the first example says write an equation of ellipse with vertices at 5, 0, negative 5, 0, and co-vertices at 0, 3, and 0, negative 3. So one of the first things that I like to do whenever I'm having to write an equation is first of all take all the information and graph it on a graph real quick. So 5, 0 would be right 5, so there's 5, and then to the left 5, because my vertices are at 5, 0, negative 5, 0. So there's my vertices, and then it says to go up 3 and to go down 3 to create my co-vertices. Right there, that shows me that my graph is going to look something like that. I will also notice that this graph is a horizontal ellipse, which if it's a horizontal ellipse, it means that when you write your general or your standard equation, your a squared is going to go with the x value, and then the y squared will go with the b value. And so we know that the general equation is going to look something like this. So in order to write this equation, what we have to do is we have to come up with h, k, a, and b. So over here on the side, what I do is I look for h and k. H and k, remember, if you remember that, it comes from the center. The center of this particular function is going to be right there. That right there is 0, 0. You know that because of where the vertices and the co-vertices are located. We also need to know a and b. We can find those fairly easy. A is the distance from the center to the vertices, which is which is 5. And b is the distance from the center to the co-vertices, which in this case is 3. So then I can figure out what a squared is 25. So that's a squared. And then we can figure out b squared, which is 9. Now we're ready to write the equation. The equation would be x squared over 25 plus y squared over 9 equals 1. Why did I not put the zeros in there for minus h and minus k? You can, but to clean it up, whenever you do that, x minus 0 is just going to be x, and y minus 0 is going to be just y. So there's no need to put that in there because this is the best equation for that particular graph. All right, so let's look at another one here. Again, it says write an equation of ellipse with vertices at 7, negative 2, and 7, negative 20, and co-vertices at negative 1, negative 11, and 15, negative 11. So what you do is create a sketch real quick, and again, I'm just going to estimate this. So I'm going to go to the right 7, down negative 2. So there's one vertice, right 7 down to negative 20, and I'm just estimating that. The co-vertices are negative 1, negative 11, negative 1, negative 11, which would be right in here, and then 15, and then 11, which would be right in there. Now this graph is going to look wider than it is tall because I didn't make a very good sketch. It's not. But remember, these are the vertices because that's what it tells us. Okay. If you want to make this a little more accurate, what we can do is we can scale this back and make it a little bit better so it looks a little more normal. So if we go to the right 7, down negative 2, right 7, negative 20 would be way down in here, and then negative 1, 11, negative 1, 15, and it would look something like this. I know it's not much better, but it looks a little bit better. Okay. If you're on an actual assessment, you'll be given some graphs to graph this, so that will help. Okay. Again, this is going to be a vertical ellipse, so that means it's going to be x minus h squared over b squared. Okay. Plus y minus k squared over a squared. And how do I know that? Is because it's taller than it is wide. Is that right? 18. Yep. Okay. Equals 1. So what is the center? The center is going to be this point right here. Well, what is that? That is an x value of 7 and a y value of negative 11. I need to figure out what a is, and I need to figure out what b is. A is the distance from the center to the vertices. Well, how far is it from this 11 all the way up to negative 2? That would be a distance of 9. And then how far is it from the center all the way out to the co-vertice? Well, that's going to be at the center is at 7, and I got to go out to 15, which would be a distance of 8. So notice the A and B value are really close, which means it's going to look really close to a circle, but it is going to be a little bit longer up and down than it is wide left to right. So then you can figure out that A squared is 81 and B squared is 64. Now what you're doing is you're ready to write your equation. So it's going to be x minus 7 squared over 64. Notice the b value goes with the x. Then it's going to be y plus 11, because it's going to be a double negative, squared over 81 equals 1. And that's how you come up with an equation for an ellipse.